This graph here, which looks like y equals 4, it's all the points that are 4 high. This graph of a function called f is given to us, and we're asked for the domain and the range. And domain and range are kind of hard to understand, but they're kind of easy to work with if you have a picture. So the domain is simply all the x values of all these points. And so there's an x equals 1 here, and an x equals 2 here, and 1.5 here, and it's all filled in. All the negative ones are filled in, and furthermore, these arrows are going forever in each direction. And so when you're asked for the domain, you're asked for all those x values, and basically it's every real number on the x number line, because there's a point for every single x value. Now the range is all the possible outputs, all the possible heights of these points. But there's not very much variation. All of these are exactly 4 high. So the range is just the number 4. That's it. Instead of being all real numbers, it's just a 4. It's easy work, but it's a confusing idea to many people. So again, we're asked for the domain and range. Here's x equals 0. On the x number line, and there's a point on our function, x equals 1, a point on our function, x equals 2, x equals 3. There's all the points in between, and these arrows seem to go up and out forever. And if they do go up and out forever, then it looks like if we take a look at all the different x values, everything gets represented. So once again, the domain is all real numbers, but the range is kind of the various heights, and there's something about the height of every single point on this function. The height is never smaller than 1 because this vertex has a height of 1. So the range could be written lots of different ways. If we use set builder notation, it would be the set of all y's such that y is greater than or equal to 1. If we used interval notation, it would be 1 up to infinity, but we would want to include 1. Or we could just describe it. The range is all numbers bigger than or equal to 1. So we could describe the range this fancy way, or a less fancy way that gets the job done. The range are the heights of the points on the function. The domain is all the different left and right positions of points on the function. So the function in problem 29 is a line with a point missing. The missing point looks to be x equals -2, and the output, which we could call y, or the output of the function f of x, is -4. That's the point that's missing. So what is the domain? What is the set of all the x values of all the points on our function? Well, the domain is really everything, all real numbers, except x equals -2. There is no point on there where x is -2, so except x equals -2. Now that's one way you could describe it in words. You could use set builder notation. If you tried interval notation, it would be just a little bit tricky. So all real numbers except -2, or all numbers except -2 is a pretty good answer. The range is similar. It's all the heights of all these points, but we're missing the height of -4. There's no point on this line that has a height of -4 because we skipped that point. So the range is all real numbers except y. I don't know why I'm writing x. Y equals -4. And I think that's a pretty good way to answer these. It looks like this picture of this function doesn't have any negative x values. So it looks like if we used interval notation for the domain, it would be starting at 0 to include 0 and going up to infinity. those through infinity, whatever that means, going forever to the right. And that's the domain. Now what about the heights? Well, it looks like the heights of these points start at 0 and keep on going. Now it is kind of hard to tell if this is flattening out, or does it just keep getting higher and higher and higher and eventually gets 1,000,000 high and 1,000,000,000 high. It's really hard to understand, so I'm going to just say in my mind that it just keeps getting higher and higher, so eventually it'll be 1,000,000 high. I don't really know for sure that that's true, but that's what I'm saying. And so the range would also be all the numbers from 0, including 0, forever upwards.